All right, good morning, pre-calculus students. It's Monday, October 9th, and a little bit more on transformations and also on how these transformations are really the same for like quadratics, square roots, and absolute value signs. I want to take a look at, first of all, the square root function. So we really want to start to be able to, when we see what the square root function is, or the quadratic function, or an absolute value function, we want to be able to make a quick sketch of these things and then be able to do some analysis afterwards. So the square root function, I like to call it the check mark. It really just kind of looks like a check mark. It's gonna kind of go like so. There's the graph of the square root function. Why does it look like that? If you were to make a table real quick, so f of x, we notice first right off the bat that, look, -1 is not in the domain of this function. I can't take the square root of a negative number in the real number system. So there's not in domain. So that's why this function starts right here at 0, 0. I think that should be pretty clear. So what about 0? Output 0. What about 1? Output 1. What about, I'm choosing numbers that are perfect squares. What about 4? 2. What about 16? 4. What about 25? 5. So this is a gradual increase on the f of x, where the input numbers are getting really large, but it's not really rising all that fast. So that's what the square root function looks like. How would you describe its domain? Okay, the domain is x such that x is greater than or equal to 0. There's its domain. Okay, so what would happen if I had another function g of x and it was equal to the root of x minus 1? Okay. What would that look like? Well, we just saw a sketch of the parent function, and then what I'm trying to also get you to think about is that these transformations are much like just the one we were just talking about with the absolute value sign. So this g of x function is going to start at 1 comma 0, and it's going to have that same shape. Looks like a check mark. It's almost just like, it's like the way the root is. That's I'm trying to get you guys to remember. It looks just like the way that we make square roots. So that way we can, this is g of x, so that we can remember what these functions look like. Okay. What's the domain of g of x? Okay, well, let's think about that. That's going to be, the domain is x such that x is greater than or equal to 1. Okay, so there's your g of x function. Okay, next. Let's make it a little bit trickier. What if we had an h of x function and it was equal to the square root of 2x minus 3? I think some of you guys could probably do that right in your head right now and notice that the vertex is at, what was that, 3/2? Let's check it out. So I'm going to set this right here equal to 0. 2x minus 3. Why am I doing that? So I know where its vertex is. x is equal to 3 halves. That means that when I set this guy right here equal to 0, that is where the vertex is of this square root function. So there is 1, there's 2, there's 3, 1, 2, 3. So 1, 3 halves, about right there. It's going to have that same pattern. It's going to go off like that. I'm just talking about sketches. What's the domain of this? X such that x is greater than or equal to 3 halves. Okay.